Hello everybody, thank you for your attention for my little talk. And today I'm going to talk about the SaltStack. Anyone is familiar with that thing? Yeah? No? Okay, that's pretty good because it's basic talk. And if you are already familiar, I think you will not be very interested in here. Well, a couple of words about me. My name is Alexei Genus. I work at Sapir.ru. My last week there, I have new job. And also my name is why the hell something doesn't work. Well, what is SaltStack? SaltStack is, as defined on official website, is intelligent orchestration software for the software-defined data center. But basically, it's just a place where you store your configurations and how you deploy it. On the other hand, Salt is just a remote execution framework as its core part. And every service Salt provides is based on this simple truth of remote execution. Well, if we are to compare Salt to another stuff like that, for example, Chef, Puppet, Ansible, here you can see the main difference are that Salt is pretty new to the industry, and it's written in Python instead of Ruby, which was widely used for Chef and Puppet in the earlier times. Does anyone use some of these tools in production? Chef or Puppet? Ansible. Okay, okay. That's a shame. I think to use Chef and Puppet now because they are. Well, they have some disadvantages. And when we chose this platform for our company, we wanted to get some thing which will cover all our use cases for the simple configuration management, for continuous delivery, and for some basic provisioning of our bare metal servers. We use only bare metal, like old school guys. Well, actually, if you compare these tools, you will understand that they all have much in common. Well, the Ansible is a little bit different because it doesn't require you to use local agent on every node, and sometimes it's said that it is a very good advantage, but I don't think it's actually important. If you have a large scale installation, well, one more daemon, okay, why not? Let's dissect Salt into parts. Well, it consists of Salt Master, which is a server node from which all clients get the jobs to do, and a client in Salt is called a minion. Well, the basic execution flow is going from the top of this slide to the down. Salt Master takes some commands to execute, serializes them into jobs, and then sends them to minions. Minions get these jobs, they serialize it, execute stuff, return results. That's the simplest case of how SaltStack execution flow works. If you have so many minions, like for example 1,000 or more, you probably need to have the syndic daemon, which is simply a SaltMaster proxy. Well, with syndic it works like that. SaltMaster gets a list of minions to execute, serializes jobs, divides this list of minions into parts, sends these parts to syndic, and syndic proxies this information to minions, gets the results from minions, and then takes only aggregated information about results to master. that is how Salt can be used in large-scale installations. Well, there are some common parts which we need to know before we get started with working on Salt. The first one is execution module, or simply module. This is anything that can be done. In the actual code, this is just a Python function on the inside of it. In this case, I am showing an example of the simplest module that can ever be. Test ping module, which does nothing. It just returns true every time. So this command, which is listed here, begins with salt. This is a command line utility, your bridge to Salt master. The star means that this is the targeting expression. The star means execute stuff on every minion you have. It can be a little bit complex. For example, you can filter some minions if you don't want to execute your commands on every minion. And test.ping is just the name of this module. The result is always a YAML, which is whose keys are minion names, minion IDs, and the results are the nested YAML. In this case, it's just true. Salt grains are the static data assigned to a minion. Well, it can be anything, any property that minion has. For example, in this case, it's kernel version, OS version. OS code name is a pretty much in use. For example, if you are working with Debian, then that will be JC, Stretch, or something else. Well, I mostly work with Debian, so I will give you an examples of Debian stack. You can also add your own grains. For example, if you have several data centers, you can assign a data center name to any minion and somehow use it later on. The state is, as its name, a state in which a minion should be. A state goes into state files where, well, this is the actual code used for minion to execute, to get into these states. For example, here we use a pkg repo.manage state, which means configure an entry in my etc sources list file. For example, here we define a .dep repo. A state file is usually, in most cases, is a YAML file, and it is templated by Ginger. For example, here you can see that we use this grains auth code name variable, which will be, for example, JC or Stretch, after Ginger gets its work. Another thing which is important for Salt infrastructure is SaltMine. SaltMine is a way for one minion get the information from another minion. For example, here we use command salt call, which means get me the minion, the current minion of this local machine. Execute mine get execution module, and arguments for this mine get execution module. Minion 1 is just an ID of minion for which we get these IP addresses, and as a result we get pretty large YAML with, as usual, keys are minion IDs, and a result is, for in this case, a list of IDs, or a list of IPs. You can also query many minions at once. Then you should change this minion1 to, I don't know, this star or something else. A pillar is a data store where you store your secrets. In the simplest case, it's just, as usual, YAML file where your data is. For example, here there is a configuration which will be applied to your SSD server config, and here we define some keys, some permit root login property, and so on. Pillar can be not only files, it can be any database. It can be MySQL, it can be even HashiCorp Vault, if you know what it is. It can be a Git repository. For example, you can take your secrets into another separate Git repository, restrict access to it, and then Salt will get this repository for pillar data. This one is my favorite part. Well, the output, as you see, is usually a YAML file, but a YAML output. But you can make it look something else. For example, you can output in JSON. Even you can output in some other, I don't know, format if you want. And the favorite one is Pony, which uses Pony say command and wraps it into actual output of the command. Well, there are many not so common parts of Salt. We will not discuss them today because these are plenty of them. There are thousands of them. For example, Salt Cloud, which is used to provision virtual machines in cloud provider. There are, I don't know, reactors, there are engines. Engines, for example, is a long-running process on a minion which does something, which emits some events, well, somehow, somewhere. It can be used, for example, to auto-scale your installations. For example, you have a minion which has very high load average, and it says to master, I have too much load average, please provision another minion to help me. And master will do that if it configured so. So let's take a look on some examples of Salt. For you, I collected some formulas. A formula is a set of Salt state files which can be reused for some common tasks. For example, this collectD formula is used to manage your collectD daemon. Do you know what collectD is? collectD is the daemon for monitoring your server. So it takes your CPU usage, your disk usage, and so on, and sends it somewhere. To apply it, we should execute a module called stateApply. StateApply collectD will be the argument, and the execution will start from either collectD SLS file, or if in our case collectD/init SLS, which is a special file which takes the that will be taken instead of this collectD SLS, because there is no such file here. So as usual, this is a simple YAML file with Ginger templating. The first line is we import some variable. Let's see what's inside. A map.ginger is a Salt, let's say, entry point for your default configurations. it defines some basic stuff. For example, this is a cross-OS formula which can be used for Debian, Red Hat, and FreeBSD. For manage such formulas, there is a special module called grains filter by. You pass a Python dictionary into it, and it gets an inner dictionary for a grain called by default. It is called OS family. Which will be Debian, Red Hat, or FreeBSD, and as a result, you will get only inner dictionary. For example, this one. Later, we set some more settings which are not OS specific, but only collectd specific. For example, we say that our default plugins will be this list. The Apache config will be here. The disk usage we will, for example, monitor every disk in our system and so on. So this is pretty much here. The last command will be this one. It takes your default settings, merges them into the settings which are gotten from your pillar. And as a result, you will get a merged dictionary with your actual config. Let's get back to this file here. So the third line is an inclusion, which includes another file into the execution flow. Collectd service, it's nothing interesting here. It just defines a collectd service and sets it to running state, and that's it. Then we install a package for collectd. Then we create this so-called plugin dconfig here, which is just a configuration folder for all plugin file for all configuration of plugins. Let's see this file managed state. File managed means that this file will be managed by Salt, and in this case it will get this file from here, and this file is a Ginger template. We also set a user group, and that's not interesting. Let's see what's inside this file. Inside this file is just a simple collectd config. Well, nothing interesting here. Let's get back. The interesting part is this. The interesting part is this watch-in statement. This watch-in statement means that if this current state has become to changed state, so it's if something changed in our configuration, execute a watch action to this service. A watch action for a service is just restart this service. So to apply configuration, that is how you can create some connections between your states and to create a requisite. For this also means that this collectd service should be configured after our configuration file will be managed. And if something fails, you will not get a result for the service state. That is how a formula works. If you can notice the interesting part here that it is heavily based on pillar data. So for collectd to do something, I don't know, important and meaningful, you should place some configuration in your pillar. And that is actually pretty bad, because you will get your pillar pretty large on the one hand. On the other hand, it will contain not secret data, because if you want to, I don't know, monitor some disk, some CPU usage, it's not that critical to hide from others. And the main downside of here is just your pillar grows, and it will be too slow to render. When you have a large pillar, the main disadvantage of this is it does not scale, because a pillar will be rendered and collected for every minion in the execution flow. So, for example, if you want to set collect D for 100 minions, then with the same config, then you will get your pillar rendered 100 times, and this will be made on master, because as an architecture of Salt is that pillar is not exposed to minions. Only rendered pillar can be used by by minions, so that they don't know a secret which belongs to another minion. So on the one hand, you get flexibility and reusage of your state, but on the other hand, you get a real performance degradation. And moreover, you will get your pillar looks strange. For you to show why it is bad to use pillar to config your data, I can show you this file, which will be rendered in nginx configuration. Well, it looks simple on the first sight, because it's only one macro. But if you look at this macro, you will see that it is actually very heavy based on Ginger Magic recursive macro, which even I don't know how it works, and this will be very hard for you to set things up if something breaks. So from now on, I'm a very big enemy of using formulas in actual production code. Now I'm going to show you how it actually works in our production code. So we have very much of Salt configurations, and I will show you this state, which as usual starts here in init.sls. It's just an inclusion of some other states which do actual work. The map.ginger is it has almost 300 lines of code, and I don't actually show you something bad here, because as you can see, this password is don't know. It will come from pillar, but in this case, pillar will be very small. It will be just these two keys there. Let's see one state as an example how it works in production. So we have this bidder state which uses these user files and Docker. So in user, we just create a user and group for this service to run. In files, we configure some configuration files and log rotate config. And in Docker, we manage Docker. At first, we download the image. Then we stop container. This state was specially made because Docker sometimes can't stop container with some weird errors like can't unmount file system device or resources busy, and that is why it works like that. So it stop gracefully, and then it does docker rm-f, and exit with success, because actually, even if this docker error -f command exits with some non-zero exit out, it will actually work. Everything will be okay. And then it starts the container. So there is a name, an image, the CMD, the user to run. These are labels which I assigned to this container, which we get from CI. When CI actually executes this state, it adds this information to pillar, and so we get all metadata of who deployed, when deployed, what is the actual, I don't know, hash sum of the commit, and so on. What is actually interesting here? This check CMD means that even if your container started well and Salt thinks that everything is okay, the logic of this service is not checked. So it actually may fall in a couple of minutes, do something bad, and so on, and you will not see it when you execute Salt. So in here, I let this service 2 minutes to start. So this is just a curl request to status page with sleep 1, and make it 120 times. And if it fails when 2 minutes, if it fails to start in 2 minutes, then we will exit with non-zero exit code and say that something went wrong. And if something went wrong, this part comes in. Fail hard means that stop all the execution if the state fails. To this, it is important not to break something in production if something went wrong. So you'd better stop early and not try to, I don't know, create this some services which will in most cases fail if the first one failed. So that is how actual configuration is done in our company. The last thing I want to say is what is actually bad in Salt. There are some disadvantages on every system, and for Salt, the main disadvantage, I suppose, is very short support time for major Linux distributions. For example, this summer, you may have heard that Debian Stretch was become stable, and that also meant that Debian Wheezy became old stable or came into the LTS phase. And also this summer, the new version of Salt was released, and it released a week after the news of Debian. And they didn't provide packages for this Debian Wheezy. However, there were no actual incompatibilities with this Debian. So I think that is well, that's not fair, because if you are a real bloody enterprise, you most probably have some old Debian old Linux distributions in your infrastructure, and this is very important to provide a support for them. On the other hand, what Salt developers say, they say that you can run different versions of master and minion, and backward compatibility is provided for all Salt master from old Salt masters to minions which run the older version of Salt. but it is very hard to use for actual users of Salt, because the development is going pretty rapid, and if you want to use some new features, you will not be able to do that, because your Salt minion is has an older version, and that is why you can use them. And if you have different versions of minions, you should be always aware of that. Some of the minions are new, some of the minions are old, and that goes pretty hard to manage. On the other hand, there are some connection problems between master and minion. Well, when you execute a command on, for example, 100 minions, then you most probably have 1 or 2 minions failed with some error like minion not connected, however it is connected. Minion did not return, however it returned. And you don't know what to do with that. So you just try to keep execution flow for a fewer number of minions to run on. And there is no IDE for Salt. This is not just a disadvantage, it's just a feature request. It will be much better to use Salt if I had some features like I don't know, find usages, refactor things, I don't know what else. Go to definition will be also very handy. So it would be great if someone will do that. I will pay any money for an IDE for Salt. So if you want to get acquainted with Salt, please visit the documentation page. It's pretty comprehensive. It's versioned. It's very good, and I in most ways don't use some resources like, I don't know, Stack Overflow or something else to actually find something unusual when I want to use it. So I'd better use documentation. It's very good. There is a GitHub for Salt. It's open source, but don't see this code. Your eyes will hurt. And they have very good YouTube channel where they provide videos from Salt conference, which takes place every year. Well, if you want to keep in touch, if you want to see what's inside, what's going on, either there, you can. You should definitely subscribe to this channel. And that is all for me. If you have some questions, please ask.
I don't know whatever. So what was the purpose of putting entries for secret data like passwords into map file, though they are taken obviously from pillar? It's just for error reporting, or in an example in your presentation you showed that there's a big map.ginger file, and then there were some password
Yeah.
fields. Why were they there rather than just pillar?
In this, you mean rather than just in state file, in this map ginger file?
Either state file or in pillar data.
Well, they are in pillar now, and I don't quite understand your question. Why should I put this don't know things there, or?
Okay, I understand. I confused a little. Then, what's your proposed solution to the problem of bloated pillar?
For you mean for using big
pillar
yeah.
with lots of data that's
So the actual question is how you scale your pillar. When it becomes too large, how you scale it? Well, you don't scale it. Actually, what you can do. I'm not sure. I'm not sure whether Syndic will render your pillar, or the rendering of pillar using Syndic will be provided by SaltMaster anyway. I don't know. I think that when you use Salt Syndic, it will actually render your pillar, and that is why you can scale it horizontally and a little bit win in render speed. But in this case, your installation will be a bit difficult to understand. It will be a bit complex. So I just try to keep pillar as small as it can be. Something else?
Well, if nobody else has questions, then if there are problems with networking or related issues for hundreds of servers, millions rather, then do you know the state of the situation when you have thousands of minions and probably use Syndic as well?
Well, I have never. The question was, do I know about some large-scale installations of Salt where more than 1,000 minions are in charge? Well, I have never seen these people in person, but well, they say that there are some people who I saw on these Salt conferences. They say that they provision many virtual machines, for example, from bare metal. So you have some bare metal pool of servers, and then you provision the virtual machine, which will greatly increase the number of minions. For example, guys from OpenStack tell that they use Salt for provisioning somewhere. So I think there are some people who use Salt at scale, but I have never seen them in person. Well, that is mainly because Salt is not very popular in Russia. I have actually seen fewer than 10 human beings who use Salt in Russia, so maybe that is why I did not see the large-scale installations.
Hey, sorry.
Okay.
And did you ever find the need to write your own modules for Salt? Not
Yes.
formulas?
Yes, I have written. I can show you some examples.
So what's your experience or feelings?
I think that it's very easy. It's just so easy you can't imagine. So one of the great advantage of Salt is that is very easy to extend by yourself. For example, I have very specific thing for managing IP addresses in our company. So every minion has a external IP address and internal IP address. And if you want to, if you don't want where your, for example, a client of MySQL server will be used. For example, you have MySQL in DC1, and you have many clients. Some of them are in the same DC, some of them are not. And if you are in the same DC, you should better use internal IP address to actually use the another Ethernet cable. On the other hand, if you are in some other DC, then you should use external IP address. So I managed to, as you see, some dirty logic of how it works, but simply it's just try to guess an internal IP, try to guess an external IP, and if they are not in the same, try to get an internal IP of one minion, of another minion. If they are not in the same DC, in the same subnet, try to put an external ID. If they are in the same subnet, then use an internal ID, something like that. And I also written deep merge by myself to deep merge dictionaries on the states side. I think it should be rewritten because in Salt from I don't know 2015 or 2016 there is a module like this, so it should be rewritten. I can also show you some. For example, this returner, a returner is a thing that takes in after the execution. So it gets the results and does something with them. And this returner takes the results, and then if some errors occurred, if some changes occurred, or in any case, so it can be configurable, sends it to some email address. Well, unfortunately, as I have some older operating systems, I could not use it, and so I just copied it into my special folder for returners, and I use this this returner on the older Salt versions. For example, it is used for managing SSH keys of our users. How it works? Well, when you provision a server, you add some keys to authorized keys file. If somebody is I don't know, not very well, if somebody puts something in this file by hand, for example, adds some evil public key, so the Salt will erase this key when the actual state is executed. And this is done on the schedule. I don't remember how exactly, like 1 time per hour it synchronizes keys with its pillar. And to know if somebody did that, maybe it was by mistake, maybe it was, I don't know, unintentionally, maybe just, maybe this developer forgot to ask sysadmins to do that, so we can see what's going on in our SSH keys. So we'll get an email, see it if something changed. That is how we use it. Well, the question is how minions know if your state file changed. Well, this is done when a minion executes some state. Actually, this state apply execution module, this is called. So it goes like that. It caches all these files on its sides and takes, well, it hashes these files, and if hash changed, it requests a master to get this file. so it will download it only if something changed. Actually, all files, these states and pillar and everything, at first are collected and are located only on master. Minion only caches these things. Yes, yes, you can. There is a special module for that. Well, but I don't use it well because the execution flow is so that a minion will definitely synchronize stuff on every state applying in any case. So you will not win very much in execution time. Salt is pretty fast. For example, when I compared to Ansible, there was well, I could not understand why Ansible is so slow. Well, my state was to create about 100 folders. It was an nginx config, and these folders were meant to store log files. And Salt creates these 100 folders like 1 second, and Ansible creates, I don't know, 3-5 folders per second. Maybe I don't know how to use Ansible, but well, I think Salt is pretty fast. So I think we should end now because there are new guys, I suppose. So if you have some questions, find me somewhere. Thank you.